Humanity has always gazed at the night sky, driven by a deep curiosity to understand our place in the universe. For millennia we've told stories about the stars, but today, science lets us ask even bigger questions. Two mysteries stand out. Are we alone in the universe, and is our universe the only one? These questions are more than scientific, they touch the core of what it means to be human. Whether we're alone or part of an infinite multiverse, the implications are profound. This journey will explore what we know, what we suspect, and why asking these questions matters. Let's begin by grounding ourselves in the observable universe. Our home, Earth, orbits the sun, tracing a graceful path through the vastness of space. From our vantage point, it's easy to feel like the universe revolves around us, but in reality, we are just a tiny part of a much grander cosmic story. The sun, our life-giving star, is only one among countless others scattered across the sky. In fact, our sun is just one of about 400 billion stars in the Milky Way galaxy. When we look up at the night sky, the shimmering band of the Milky Way is a glimpse into this immense collection of stars, gas, and dust, all bound together by gravity. Each point of light could be a sun with its own planets, perhaps even with life. For centuries, humanity gazed at the heavens and believed the Milky Way was the entire universe. Ancient astronomers mapped the stars, charted their movements, and wondered about our place among them. Their tools were simple, but their curiosity was boundless. Everything changed in the early 20th century when astronomers like Edwin Hubble peered deeper into the night. They discovered that the faint, blurry smudges seen through telescopes were not just clouds of gas or distant stars, but entire galaxies, each one a vast island of billions of stars, separated from us by unimaginable distances. With the advent of powerful modern telescopes, we can now observe thousands of galaxies in just a tiny patch of sky, no bigger than a grain of sand held at arm's length. These images, like the famous Hubble Deep Field, reveal a universe teeming with galaxies, suggesting there are at least 100 billion galaxies in the observable universe, each with its own stars, planets, and mysteries. But there's a catch: the word observable is crucial. We can only see as far as light has traveled since the Big Bang, about 13.8 billion years ago. The cosmic background radiation is the oldest light we can detect, a faint afterglow from the universe's fiery birth. Everything beyond that is hidden from view, its light still on its way to us, or perhaps lost forever. The universe itself is expanding, stretching space and carrying galaxies farther apart. Some regions are moving away from us so quickly that their light will never reach us no matter how long we wait. This means that the observable universe is just a bubble within a much larger, possibly infinite cosmos. Our cosmic census is limited by this horizon. Beyond the edge of what we can see, there could be countless more galaxies, stars, and perhaps even other forms of matter and energy. The true scale of the universe may be far greater than we can ever imagine, and what lies beyond our horizon remains one of the greatest mysteries in science. This realization is both humbling and exhilarating. It sets the stage for our first big question: what lies beyond what we can see? Are there other universes, or is there something fundamentally different waiting in the darkness? As we push the boundaries of observation and theory, we are left to wonder: could the universe beyond our sight be more of the same, or does it hold secrets that challenge everything we know about reality? The quest to answer these questions drives astronomers and physicists to keep exploring, searching for clues in the faintest light from the farthest reaches of space. The universe is vast, mysterious, and perhaps infinite, and our journey to understand it has only just begun. The idea of multiple universes isn't just science fiction. It's a concept that has fascinated both storytellers and scientists for decades. From the pages of imaginative novels to the chalkboards of theoretical physicists, the possibility that our universe is just one of many has captured human curiosity. But what if this idea is more than just a product of creative minds? In modern physics, the multiverse is not only a topic of speculation, but a real possibility supported by some of the most advanced theories in science. Physicists are actively exploring whether our universe is unique, or just one of countless others governed by different rules. Take string theory, for example. This groundbreaking framework suggests that the fundamental building blocks of reality are tiny, vibrating strings of energy. According to string theory, there could be a vast landscape of universes, each with its own unique set of physical laws, particles, and forces. These universes might be so different from ours that the very fabric of reality would be unrecognizable. M theory, an extension of string theory, goes even further. It proposes that there are up to 11 dimensions, far beyond the 3 dimensions of space and 1 of time that we experience. In this view, our universe is like a 3-dimensional membrane, or brain, floating in a higher dimensional space, surrounded by countless other brains, each potentially hosting its own universe. The mathematics behind these theories is mind-boggling, allowing for a staggering number of possible universes. Each universe could have different values for fundamental constants, such as the strength of gravity or the charge of the electron, leading to realities that are wildly different from our own. Another compelling idea is the theory of eternal inflation. This theory suggests that the rapid expansion of space didn't just happen once, but is an ongoing process. New universes are constantly being created, each one forming as a bubble in an endless cosmic sea. These bubbles never collide, and each one could have its own distinct properties and laws of physics. In this vast multiverse, our universe may be just one tiny pocket among an infinite number of others. The scale is almost impossible to imagine, an endless expanse where every possibility is played out somewhere. In some of these universes, gravity might be so strong that stars and planets can't form. In others, the building blocks of matter could be so different that life as we know it would be impossible. There could be universes with entirely new forms of matter or even laws of physics that defy our understanding. The multiverse hypothesis radically expands our sense of what reality could be. It challenges us to imagine a cosmos far grander and more mysterious than anything we've ever known, and invites us to keep searching for answers to the biggest questions of existence. Quantum mechanics offers an even stranger idea, the many worlds interpretation. At the quantum level, particles exist in multiple states until observed. Many worlds suggest that every possible outcome actually happens, in a branching universe. Every decision, every quantum event splits reality into parallel worlds. There could be universes where you made different choices or where history unfolded differently. This interpretation elegantly solves quantum puzzles, but it's deeply counterintuitive. We experience only one branch, unaware of the infinite others. Reality, in this view, is a constantly branching tree of possibilities. The multiverse is a breathtaking idea, but it's also controversial. Critics argue that if other universes can't be observed or tested, the idea drifts from science into philosophy. Some say we should focus on the universe we can study, not speculate about infinite unseen worlds. Yet philosophical traditions have long suggested that reality is deeper than what we perceive. The debate highlights the limits of our knowledge and the blurry line between science and philosophy. Whether you accept the multiverse may depend on whether you value empirical evidence or theoretical elegance. For now, the true number of universes remains an open question. Now, let's turn to a mystery closer to home. Where is everyone else? The Fermi paradox asks why, in a galaxy with billions of stars and planets, we see no evidence of alien life. There could be 50 million potentially habitable planets in the Milky Way alone. Many are billions of years older than Earth, giving civilizations a huge head start. With so much time and so many worlds, advanced life should have spread across the galaxy. Yet the cosmos is silent. No signals, no megastructures, no signs of galactic empires. The numbers say the galaxy should be full of life, but the evidence says otherwise. This is the heart of the Fermi paradox. Where is everybody? The Fermi paradox forces us to confront a profound question. If the universe is so vast, and the stars so numerous, why does it seem so silent? This puzzle compels us to explore both the darkest and most optimistic possibilities about our place in the cosmos. One of the most unsettling ideas is known as the Great Filter. This theory suggests that somewhere along the path from simple life to advanced, spacefaring civilizations, there is a nearly insurmountable barrier. It could be a catastrophic event, like a planet-wide disaster, a self-inflicted apocalypse, or a cosmic accident, that wipes out intelligent life before it can spread across the stars. If the Great Filter lies ahead of us, it means our future could be at risk. Another possibility is that life itself is incredibly rare. Maybe the conditions that allowed life to flourish on Earth are so unique that, out of billions of planets, we are the exception. In this scenario, we are a cosmic miracle, alone, but special. There are also more chilling theories. Some scientists speculate that the universe might be a dangerous place where predatory civilizations eliminate any potential rivals. In such a scenario, staying silent and hidden could be the only way to survive. Perhaps the quiet is not a sign of emptiness but of fear. But there are hopeful explanations too. It's possible that we simply haven't searched enough, or that our methods are too primitive to detect the signals of advanced life. The universe is vast, and our technology is still young. Maybe we're just looking in the wrong places, or listening on the wrong frequencies. Advanced civilizations might communicate in ways we can't even imagine, using technologies that are invisible to us. They could have moved beyond physical exploration, choosing to exist in virtual realities or digital worlds, making their presence undetectable by our current instruments. There's also the possibility that we are the first. Maybe intelligent life is just beginning to emerge in the universe, and we are at the very start of a long cosmic story. If so, the silence isn't ominous, it's simply the quiet before the dawn. The silence of the cosmos could mean doom, or it could mean that we are pioneers, destined to explore, to discover, and perhaps to fill the galaxy with life ourselves. Our journey is just beginning, and the possibilities are as endless as the stars. The absence of evidence is not evidence of absence. The universe still holds its secrets close, and the mystery of whether we are alone remains one of humanity's greatest questions. Despite the silence, humanity is searching for answers. We study exoplanets, analyzing their atmospheres for signs of life. Spectroscopy lets us detect biosignatures, gases like oxygen and methane. SETI scans the skies for signals, expanding beyond radio to lasers and heat signatures. Citizen scientists join the hunt, sifting through vast data for anomalies. On Earth, researchers try to recreate life's origins in the lab. Each approach brings us closer to understanding how common life might be. The search is ongoing, and every discovery reshapes our view of the cosmos. We may not have answers to the biggest questions, but the search itself is transformative. Exploring the multiverse pushes the boundaries of physics and math. Searching for alien life drives innovation and global collaboration. These quests inspire new generations and deepen our sense of wonder and responsibility. Whether we're alone or one of many, the implications are profound. Asking these questions is what makes us human, a way for the universe to know itself. The act of searching, not just the answers, defines our species. Our journey of discovery continues, fueled by curiosity and awe.